we are devoting a whole week to looking at a big question. Question of science. What is science? How did the scientific age come to be? It's one of 4 weeks that will take place during 2018, each of which will have another big question of its own. The next one in April will be Shakespeare and his legacy. After that, the American Republic and its founding. That's in the fall. And finally, in November 2018, the 100th anniversary, you may recall when the guns fell silent on the Western Front, we will be looking at the Great War, its aftermath, its effect on society, which was profound. So each of these 4 weeks is going to be a multidisciplinary exercise in which people from different fields of study will bring their expertise to the examination of a common subject. In addition to that, we are having a principal speaker in each of these weeks, and this week it's a very distinguished one indeed, one of the world's leading historians of science, Peter Deer, Dr. Peter Deer of Cornell University, will do the same in the weeks that follow. We're also having an exhibition. You may know the Remnant Trust, which is located here on campus. It is a 1,400-item collection of first and early edition texts of various kinds. They have quite a few dealing with the birth of, or rebirth of, or revolution in science during the 16th and 17th century. They are on display in the library. And finally, I might say, in conjunction with Professor Deer's lecture this evening, we have an essay contest in which we're inviting undergraduates who come to the lecture, and I'm sure you'll all be there, to respond to it, to take up some of the subject matter, some of the questions, some of the intellectual challenges that Professor Deer throws out. Write about it, roughly 2,000-word essay. You can find all about this on our website. We'll also have something up on the screen this evening, 6 o'clock, when Professor Deer's lecture takes place in room 169 of the Human Sciences Building, just to the east of the Administration Building. And the winner of that contest will receive a $1,000 scholarship, and there'll be smaller second and third place prizes as well. So that's open to all of you who are undergraduates here at Texas Tech. So, as I say, we have a whole series of lectures going on from different perspectives. We've had one on music and science, we've had one on science fiction, we've had one on technology and the Industrial Revolution, we've had one on ancient Greek science, and today we will, in a sense, look at the question of what science is, what defines science. Some people, like Karl Popper, have said it's testability. Maybe that's true, maybe it's not. And to find out more, I give you back to Joel.
All right. Well, so thanks for coming. The big question, actually I'll have 2 slides here, is what is science? I'm just going to start with Popper, talk a little bit about him, and then we'll go from there. So this is Sir Karl Popper. Perhaps his most famous work, The Logic of Scientific Discovery, originally written in German in 1934. It was already widely popular. Actually, it wasn't translated into English until 1959, translated as The Logic of Scientific Discovery. That picture is much older than when he actually wrote the work. And he talks about lots of things in the work, of course, but one thing that people remember, not the one thing, but one of the things that people remember the most is this question about what is science, so what he called the demarcation problem. So here's a quote from Popper. He says, the question, that is the question he's interested in, is not when is a theory true. I, Popper, wish to distinguish between science and pseudoscience, knowing very well that science often errs and pseudoscience may happen to stumble upon the truth. And this is the conclusion later in the page. The criterion of the scientific status of a theory is its falsifiability or refutability or testability. So the question, it is a hard question, of course, which scientific theories are the right ones and how to test theories. That's a good question. But there's another question that you might be interested in, which is what even counts as science in the first place? right? And there's these things that seem like science that Popper concludes are in fact not. So today, there's debates about, if somebody says that, oh, the paleo diet, that's unscientific or something. Or if you're debating about acupuncture or chiropractic, to call something unscientific is sort of a, it's a knock on it. It's to say that, oh, it's not serious or whatever. But the idea is that it seems like it's supposed to be scientific and you're really calling it pseudoscience, like astrology or something. Okay, so as an example, now that book is 1934, but in fact there's a really helpful discussion of it in the first chapter of a later work, a collection of his papers called Conjectures and Refutations, The Growth of Scientific Knowledge is the subtitle. The first chapter of that I put up on the extra readings on the website. So if you're in this class, or if you're not, you can go to my website. There's extra readings up on any given week. The extra reading, if you want to read Popper's actual words, it's sort of up there. So here he says, this is from, I think, page 2, he says, what is wrong with Marxism, psychoanalysis, and individual psychology, that is the Adlerian psychology? Why are they so different from physical theories, from Newton's theory, and especially from the theory of relativity? Perhaps I should have pointed out, he starts the essay by talking about how he grew up in Vienna, so he was born in 1902, he grew up in Vienna, and it's like this hotbed of intellectual activity, right around World War I, and there's all these theories in the air, and Freud and Adler and Einstein are sort of a big deal. And he's talking with his college friends, and they're all super impressed by all these things. And in particular, he's super impressed by the theory of relativity, as he says. And here's why. Okay, so here's the answer, and then I'll describe how that answer works. His answer, what makes relativity different from these other things, which he's going to later call pseudoscience. He says, Einstein predicted that light bends around the sun. I'll describe that in a moment. These other theories don't predict anything in particular. That is, they're consistent with any result. This is going to turn out to be the problem with these other theories. So let me say what I mean by prediction. And Popper tells this story about how he was super impressed in 1919 with the theory of relativity. And here's what it goes. Now, as you'll see, I have no qualms about just stealing slides from other people. This is just some slide from online. I just Googled it, and here's the slide. And so basically when the background changes, you'll know that it's someone else's slide. So just to sort of to give credit where credit is due. So the general theory of relativity, which among other things predicts how mass interacts with space, then space, predicts that really massive bodies, for example the sun, warp space to such an extent around them that it might even be detectable. If you look at a light ray, so imagine there's this star, say way back there, behind the sun, comes around, it would actually be warped around space. And so when you look at it, it's not in the place that it should be, right? And this is normally not detectable because the stars are really close to the sun. Of course, the sun sort of blots them out. So there's this prediction, but there's no obvious way to test whether it's true. But it turns out that during a solar eclipse, you may remember if you looked at the eclipse from last year, you can see all the stars right around the eclipse because the sun is dark. So what happened in 1919, here's the naive version of the story, we'll come back to this later. It's predicted there's going to be this solar eclipse. In particular, it would be visible from the west coast of Africa. So Arthur Eddington, the royal astronomer in Britain, and a whole team of people go down to Africa, get their big telescopes, take pictures of the solar eclipse, measure exactly the positions of the stars there, and then they, let's see, how exactly do they calculate? So they take 2 photographic plates and measure the distance that the star, that is the change in the apparent distance of the stars. And here goes the story. Einstein predicted that it would be off by X amount. They measure it, bam, he nails it. Einstein's famous. It's the front page of the, actually not the front page of the Times of London, but it's in the Times of London. Einstein's famous, he's a hero. So science is great. That is, the general theory of relativity makes this prediction. And then a couple of years later, so theory of relativity is published in 1915. A couple of years later, this astronomer goes and checks it. Turns out it works. And this is how science works. This is what makes a scientific theory great. But in particular, relativity is a scientific theory because it could have failed. That is, they could have made the measurements and the light wouldn't have bended, and then it would turn out that relativity is false. So relativity is a scientific theory. And that's exactly the problem, Popper says, with these other theories. So the Marxist theory of history, for example, economic history, says there's going to be this, revolution. People will rise up, and if there's not a revolution, you say, oh, that's because it's been stamped out by this other thing. And he says, if the newspaper publishes this thing, it's great. If they don't, then you know that the reason they don't publish is because of the oppression of the newspapers and population. Or whatever. So no matter what happens, and with Freudian psychology, his example is if somebody saves a drowning child, you're like, oh, right, they've got this. I obviously know nothing about Oedipus or about the Freudian complex. So one of the problems, if they save the child versus let the child die, one of them is explained by some sort of sublimation, one of them is some sort of Oedipal complexion thing. And Adlerian psychology is the same thing. He says basically no matter what happens, the theory can say, oh, yeah, I got that. I can predict that. I can confirm that. And you can never actually show that it's false no matter what happens. Okay, so that's the difference for Popper between science and pseudoscience. Here's just a sort of a basic idea of what falsification looks like. So the sort of the traditional way you think about confirmation, if you read your scientific method in page 1 of your physics textbook or something, you might have this hypothesis, and you say, if this hypothesis is true, I'll get this observation. And then you go check, you get the observation, so you conclude the hypothesis is true. Popper says, no, you don't do that. That's total garbage. That's actually a logical fallacy, sort of affirming the consequent. It's deductively invalid. This is the true scientific method. What distinguishes science from non-science, it turns out, is its method, is the possibility of finding finding something other than your observation, which would in fact falsify the hypothesis. So what science does is it makes these bold conjectures that predict precise observations, and then you go check. If it turns out the observations show that the theory is false, fine, you pick a new theory. If they don't, you don't conclude your theory is true, you just don't yet get rid of it. But this is the scientific method, and this is how it works, and it's sometimes thought of as just the falsification method. And Popper is everywhere, by the way. This is sort of apropos of nothing, but I happened to just be reading this book, I think 2 weeks ago or something, about the origins of life and the scientific quest for the origins of life. And just offhand, he's talking about what makes a good scientific theory, and he says any acceptable scientific theory must make testable predictions, otherwise, as Karl Popper consistently maintained, the theory is just idle speculation. And this is totally random. Trust me, I could do this with, 10% of popular science books that are out there. They just mention Popper offhand, like, of course we all know Popper's right about this. It's a very common thing to distinguish science from non-science and to specifically cite Popper with no real thought as to whether it's actually right or not. Okay, now I mentioned this slide quickly because it's going to come up later in the talk. Famously, Popper, it's actually famous that he has a problem with evolution, even though if you look at the details, it turns out he really doesn't. He's actually quite knowledgeable. He has a pretty good understanding, actually, of how biology works. But it's pretty easy to cherry pick quotes where it looks like he's really critical. And in particular, this quote was reprinted in a work we're going to look at later, Scientific Creationism. So these creationists pick out this quote from Popper. They say, even the great Karl Popper thinks that evolution is not science, which we'll talk about in a moment. So here's this quote from Popper. I've come to the conclusion that Darwinism, he really just means natural selection in this particular quote. It's not a testable scientific theory, but a metaphysical research program. So in particular, it's not science. So Popper has this theory about what is science. Namely, science is testable. It makes testable predictions. If it does, it might be good science, it might be bad science, but at least it's science. If it doesn't make any predictions at all, it's not even science. It's not even a player on the table. It's like astrology or some other kind of made-up theory. Okay. Now, what I'm going to do is, it's going to seem like a side note for about 5 minutes, and like, why are you talking about this? But it turns out there's really interesting discussion, I think, to be had about when you think about whether evolution is a science and why, and whether Popper can sort of capture that. And it comes out in a lot of these court cases dealing with the teaching of evolution in schools, evolution in creation science. And to do that, I want to just do a little bit of history of some of the court cases. The first ones didn't really talk about the nature of science. But it sort of starts, any talk about legal battles and evolution has to talk about the monkey trial. So the Scopes trial, you may have heard of this, in 1925. It's called the monkey trial. The details are actually pretty interesting, but I'm trying to ignore as many of the details as I can. Basically, there's this law in Tennessee called the Butler Act. It, in fact, wasn't the only state. Like, many states had laws like this. So this is an act prohibiting the teaching of evolutionary theory in all the universities, all the public schools, etc. In Tennessee, it specifically provided, here's a quote from the law, "It shall be unlawful for any teacher in any of the universities, normals, and other public schools in the state to teach any theory that denies the story of divine creation of man as taught in the Bible, and teach instead that man is descended from a lower form of animals, or lower order of animals." So that's the law in 1925. Can't teach evolution. In fact, Butler, the person who wrote the law, didn't actually know anything about science. The legislature, he just said, "Oh, I don't know anything about evolution. I just read in the papers that boys and girls were coming home from school telling their fathers and mothers the Bible was all nonsense." So they wrote this law, and William Jennings Bryan, a famous American statesman who had run for president 3 times on the populist ticket, lost all 3 times, but he was still a major statesman. He wrote to the governor and said, "The Christian parents of the state owe you a debt of gratitude for saving their children from the poisonous influence of an unproven hypothesis." This is noted here in particular because it turns out that he became the chief, he was the prosecutor in the case. That is, they asked, so what happened is this high school teacher, in fact not a biology teacher, John Scopes, basically said, "Yeah, I'm willing to flout this law and be sued and go to court on behalf of the ACLU." So he just said that he did, even it's not actually clear that he in fact taught evolution at all. He's like, "Yeah, I did." So the ACLU and Dayton, they arrested him because they wanted to make a big deal out of this, because they wanted to they thought it would bring in newspapers and tourism, and the court case would be fun, and bring some attention to Dayton. Right? So, and then they got William Jennings Bryan willing to try to prosecute Scopes. Clarence Darrow, the famous lawyer, was lawyer for the defense, the ACLU, recently had defended, is it Lewis and Loeb? Leopold and Loeb, who had been arrested for various murders, and said, "Oh, they had to do it, they don't have free will anyway." So here's William Jennings Bryan. But it's sort of important to note, and often forgot, that in fact the ACLU, that is Scopes, lost the case. The law says you can't teach evolution, and he's like, "Yeah, I did it." He lost the case. Now, looking back, people think of it as this great battle between science and religion, in particular because of this absolute absurd moment where the judge allowed Darrow to call Bryan as a witness. So the chief prosecutor was on the witness stand as an expert on the Bible. And Darrow's strategy was he was going to try to claim that, in fact, teaching of evolution, in particular human evolution, was not actually contrary to the Bible, because you should not read the Bible literally anyway. So he put Darrow on the stand as an expert on the Bible and asked him questions like, "Do you really believe in the flood? Do you really believe the earth was created this young? Where did Cain get his wife?" Questions like that. And if you want to sort of read about this, there's some great stories. There's originally a play and then a movie, which is extremely biased, by the way. You have to really understand. It's called Inherit the Wind. The original movie is Spencer Tracy, is Clarence Darrow. There's a new version with Jack Lemmon, I think, is the prosecutor. Anyway, there's a PBS, if you want to know that. But this treats it like this great battle between science and religion, where science just wins and religion looks like idiots. But that's in fact not what happened. If you want a more accurate story, you can watch the PBS version on the monkey trial, or read this amazing Pulitzer Prize-winning book by Ed Larson called Summer for the Gods about the monkey trial. But you sort of have to mention that because the more modern trials, they're often called things like Monkey Trial 2 or Monkey Trial 3. So you sort of have to know about this famous trial in American history. So just remember the law said that you can't teach evolution, and Scopes did and lost. So there was nothing, I mean, he did teach evolution, it was illegal. But eventually this law was overturned. So this is a Supreme Court case in 1968. How do I not have the date up here? I'm pretty sure it's 68. Where the court ruled that the Constitution does not permit a state to require that teaching and learning must be tailored to the principles or prohibitions of any particular religious sect or doctrine. And they believed that preventing the teaching of evolution was effectively religious doctrine. You might think about that and think, why? Why is not teaching evolution, why does that count as religion? I kind of think it shouldn't, but that was the rule of the Supreme Court in 1968. So it used to be you couldn't teach evolution, now you can't have a law preventing evolution, and so the new idea was that they would try to have these equal time laws. So this book was written, let's see, 1974. So in the 70s, the Institute for Creation Research started and various other things. Their idea was that they thought they had scientific evidence for a young Earth, 6,000 years old, and for example, for the flood. Henry Morris was a co-author on this book called The Genesis Flood. There's a longer version of this book, Scientific Creationism, that includes all these biblical references about how science basically lines up with the Bible. But then what they did was they created this public school edition, basically stripping out all of the Bible references. This book is obviously kind of gone out of fashion, but I found a copy for $1 at the library book sale. So here's this public school edition textbook, which is meant to be a science book, right? So if you page through this book, they don't talk about the Bible. They talk about scientific evidence for creation, in particular lots of evidence against evolution. And the idea was, well, okay, this would pass muster with the courts if you had laws that said, you don't have to teach evolution or creationism, you can sum up, but if you do, you have to teach both, right? There would be sort of equal time laws. Okay. Now, part of what ended up sinking them is there's a rule that comes from Lemon v. Kurtzman, U.S. Supreme Court law, that the intent of a law matters a lot. So in this case, the question, I'm going to talk about a Supreme Court case in a moment, the question is about whether teaching scientific creationism counts as promoting religion, right? Because the First Amendment of the Constitution has an establishment clause preventing Congress, or really any state body, from promoting or supporting any particular religious doctrine. The question is whether things like this, whether anti-evolution laws or teaching scientific creationism are promoting religion. And the Lemon test includes things like what the intent behind the law is. And Henry Morris, dug his own grave by writing a whole flood of other clearly religious documents. So it was obvious what the intent of the book was. So for example, this is not in the Scientific Creationism book, but this is the same author. Right? He says evolution is at the foundation of communism, fascism, Freudism, social Darwinism, behaviorism, Kinseyism, materialism, atheism in the religious world, modernism. As Jesus said, good tree cannot bring forth corrupt fruit. In the view of the bitter fruit yielded by the evolutionary system over the past 100 years, a closer look at the nature of the tree itself is well warranted today. These kinds of quotes are especially important for people in my class, because later, when we talk about evolution and ethics, and for example, we'll read Willington, it's Brian, and other people, it's clear that a lot of what's behind the anti-evolution movements is this thought that there must be a connection between acceptance of evolutionary theory and, for example, the overthrow of traditional moral rules. And that puts a lot of pressure on this supposed separation between science and religion. So it's important for our class to sort of think about these things. And it's not like he's the only guy that said this. This is also from the Institute of Creation Research. So the idea is, so evolution is this tree. At the root, it's promoting all these things. Humanism, racism, paganism, abortion, all these disastrous things. And if you can chop down evolution, you can sort of do all of this. They're not the only group. This is a 2004 slide from Ken Ham, who's the head of Answers in Genesis. Ken Ham, some of you may know, debated Bill Nye in 2016 It was on CNN and other things, it's sort of famous. Bill Nye the Science Guy debating Ken Ham. This is a slide from Ken Ham where evolution is sort of trying to destroy God's word and creationism because they like all these things, pornography, racism, euthanasia, etc. Unless you think this is some kind of one-off thing, in fact, this slide goes back more than 20 years. This is the original version. A few things have changed. For whatever reason, they changed divorce to family breakup. They changed homosexuality to homosexual behavior. Not sure. But so here's Ken Ham about this slide. He says, there's this discussion, he says, I'm remembering back 20 years ago when we made this slide, etc. He says, while Christians could see the increasing rejection of Christian morality as well as the growing acceptance of abortion, homosexual behavior, family breakdown, etc., they couldn't see the foundational reason. Christians were fighting only the issues such as abortion when in reality they were just symptoms of the real problem, the loss of biblical authority, beginning with Genesis. We wanted to represent this artistically and as a castle illustration beginning with. So it's changed over time. Why am I mentioning all this stuff? Because it really sunk the case for creation science in the courts, because they thought, well, look, it's obvious, this book is just a copy of a religious book with the religious stuff stripped out. So obviously the intent is to promote religion. And we'll see how this has evolved in the court cases. So the first sort of major case, it was tried in 1981, but the decision was in 82, where they struck down equal time laws. This is McLean v. Arkansas. For those of you in this class, this is Stephen Jay Gould. We read work by him. He was one of the chief witnesses for the, I guess it would be prosecution. That's the Attorney General of Arkansas, Steve Clark. And here's this ruling. Now, here's why we're talking about this right now. This is the ruling from Judge Overton, who says scientific creationism is not science, it's religion. So first of all, they're already thinking that if it counts as religion, it can't count as science, which you should know from this class is not a clear inference. That may be a bad inference. But the idea was it's religion, it's not science. And in particular, he said, this is an official court document. Here's the essential characteristics of science, he says. First, it's guided by natural law. Second, it has to be explanatory by reference to natural law. Third, it's stable against the empirical world. Its conclusions are tentative, not necessarily the final word, and it's falsifiable. This is from a federal judge saying it's now official policy of the United States government that science is falsifiable. Now this, in fact, comes almost directly from one of the witnesses, Michael Roos, who is a philosopher of science. You can read all the transcripts online if you wish, like I have. And so, for example, here's Michael Roos talking. This is the concept of falsifiability, something which has been talked about a great deal by scientists, others recently. It's an idea which is made very popular by the Austrian English philosophist. This is in the transcript. I don't know if that's Roos or just the person typing. Karl Popper, basically the idea of falsifiability, etc. Alex, you got a quick question?
Yeah, sorry if this has been asked before, but are these slides on Blackboard?
No. So I might put some of, now actually we're recording this. So these are going to be online. I will find out the details, and I can put these particular slides up on Blackboard, but they're not there yet. I mean, I just
so
wrote
we're
them,
recording
like literally this
Black-
morning.
We're recording each
Yeah,
slide,
it's being recorded right
and
now.
I can listen to it on Blackboard.
I'll have to think about that. I mean, I'll have to see how exactly it works out, but
Alright, cool.
I will certainly let you guys know.
Okay, thank you.
So this transcript from the court case, this is Michael Roos talking about Popper, and it made its way into the judge's decision. And of course, it was completely foreseeable that Michael Roos was asked by the defense, by the Deputy Attorney General of Arkansas, about Popper's views on evolution. It's like, wait a minute, you're using Popper to say that scientific creationism is not science, but Popper doesn't think evolution is science. So here's, he was asked about this, and here's Novik. This is so the prosecutor interrupts and says, wait a minute, excuse me, Your Honor, we learned from the Attorney General yesterday, he wants to try to demonstrate evolution is not science, that evolution is religion. This line of questioning, it seems like that's where they're going. The plaintiffs contend this entire line of questioning is irrelevant to the proceedings. Evolution is not an issue in this case. Now, if you just ask somebody what this case is about, they'll all think it's about evolution versus scientific creationism and about which one is science and which one is religion. But for legal reasons, evolution is in fact not in question. What's in question is scientific creationism. Now, this is lawyer speak. They're not claiming that evolution is not science, but they're basically saying we don't want to talk about that. We don't want to talk about whether evolution is science. We want to specifically point out that this other thing is not scientific creationism. I want to make this point because if I have time, I will. We'll come back to asking this question about whether evolution is actually science and why. And in particular, my own opinion is that if falsifiability, if what they said, if these criteria were right, it's pretty reasonable actually that evolution is not science. That's my own view, but that's because I think these criteria are wrong. Okay, this case, so what happened there, I don't have a slide for some reason, is that the Arkansas law was overturned. So these equal time laws were overturned. It was declared that scientific creationism is in fact not science, it's religion, and so therefore can't be taught in public schools. There was another law in Louisiana, basically exactly the same. That one went all the way up to the Supreme Court. Here's Edwards v. Aguilar. Gould testified again. And the Supreme Court went with the original judgment and said, yeah, they're right. Creation science is not science. Now, is this the end of sort of creationism? Well, this is a ruling from the court. They point out this is Justice Brennan writing, says teaching a variety of scientific theories about the origins of humankind to school children might be validly done with the clear secular intent of enhancing the effectiveness of science instruction. So the ruling was heavily based on this idea that this book is actually religious instruction, not scientific instruction. So they say, well, if it was meant to be science instruction, then of course it would be okay. And so what happened then is that there was the sort of modification of, the biased way of putting it, I'm not sure I believe this, but the biased way of putting it is that basically creationism just evolved. The same authors who wrote these creationist texts then just wrote other texts saying, no, we're not creationists, we're defending this other thing, intelligent design. This book is going to be important in this Kitzmiller trial, so I'll mention it here. So intelligent design is sort of the buzzword for the next court case, and it's relevant to this book of Pandas and People. So intelligent design sort of as a movement, you can sort of pinpoint it by talking about various books like Darwin on Trial, Darwin's Black Box, this is William Dembski, Philip Johnson. So there's a whole series of these books especially the early 90s was probably the most popular time. But the foundation of this arguably didn't really change at all. So this is the Discovery Institute where today intelligent design is sort of promoted and supported materially with money and things like that. And this is somebody who works there. So it's saying basically exactly the same thing that Henry Moore said before. Our view of origins shapes our understanding, etc. If life on Earth is a product of blind, purposeless natural causes, our lives are cosmic accidents. There's no source of transcendent moral guidelines, etc. This is why there's this famous Wedge document where the Discovery Institute, which is now called the Center for Renewal of Science and Culture, they basically just say that their goal is to defeat scientific materialism in this destructive morale. Just look at this quote in the middle. The center seeks nothing less than the overthrow of materialism and its cultural legacies. So they supported various kinds of laws which are sometimes called teach the controversy laws, where they just sort of wanted to point out problems with evolution. And now I'm going to move to this other court case. So this is Dover, Pennsylvania. And in 2004, this is the headline, intelligent design voted in. That is, the school board said, yeah, we want to promote intelligent design in our classrooms. Now, here's a New York Times article. So this is getting national press. Of course, they're already calling it, Scopes 2 and Monkey 2, etc. But in fact, if you look at what happened, you might think this totally trivial, minor thing. Even though the school board said they would like to see equal time, or that they would like to see teach the controversy, etc. In fact, what they ended up doing was pretty minimal. What was actually passed was this statement that they wanted the 9th grade biology teachers in the district to read to their students. So we're talking 2 minutes out of the course of the entire year. Okay, now here's the statement. Right, I'll just read it. It's worth hearing. So the idea is, I teach 9th grade biology and we're about to teach evolution, and so I'm supposed to read this statement to you. The Pennsylvania academic standards require students to learn Darwin's theory of evolution and eventually take a standardized test which evolution is a part. Because Darwin's theory is a theory, it's still being tested as new evidence is discovered. The theory is not a fact. Gaps in the theory exist for which there is no evidence. The theory is defined as a well-tested explanation that unifies a broad range of observations. Intelligent design is an explanation of the origin of life that differs from Darwin's view. And now, they're not even teaching intelligent design, they just say, the reference book of Pandas with People is available for students to see if they'd like to explore this view in an effort to gain an understanding of what intelligent design actually involves. They put about 40 copies in the school library and said, you can go look if you want to read this. As is true with any theory, students are encouraged to keep an open mind. How could that be bad, right? Keep an open mind. The school leaves the discussion of the origins of life to individual students and their families. As a standards-driven district, class instruction focuses on preparing students to achieve proficiency on standards-based assessments. So, in fact, all that happened is that the school board said, we're going to read this statement, and put up Pandas with People in the school library. But many parents and the ACLU and science educators across the country were outraged that this is effectively teaching religion in their schools. And so, of course, it went to trial. So, and it's the famous one because the trial was first, but in fact, there's legislation all across the country at exactly the same time with basically very, very similar bills and laws going on. Coast-to-coast challenges, it says. Here's Dover, Pennsylvania. Here's a picture of the trial. At the trial, the book of Pandas with People was on display. Basically, if it counted as a science textbook, it just seems, even if, and this is important, even if it's bad science, it's not illegal. It's not illegal to teach bad science. The claim was that, in fact, this is promoting religion, which would then be unconstitutional. Okay, here's the ruling: intelligent design is not science. Okay, why? Well, the ruling from this, in this case, Judge Jones III, Johnny Jones III, was a little bit different than the original McLean v. Arkansas ruling, but not much. Okay, so here, this is another thing that I'm mentioning because it's important to our class. The move in the Judge Overton ruling in 1982, yes, natural law was mentioned a lot, but also falsifiability. Here, it's really changed to this discussion about the supernatural. And the idea was that intelligent design requires a designer, that's supernatural, that's religious. So this is from the ruling: ID violates the centuries-old, it's not centuries old, ask Peter Deere, he'll tell you all of this, rules of science by invoking and permitting a supernatural causation. This, frankly, I don't even really understand. The argument of irreducible complexity central to ID employs the same flawed and illogical contrived dualism that doomed creation science in the 1980s. That is, it's not really any different. And third, which should have nothing to do with religion, actually, ID's negative attacks on evolution have been refuted by the scientific community. So, there were experts, Michael Behe and other biologists testified that ID is scientific. It consists of, for example, criticisms of traditional Darwinian natural selection story, and then prosecutors brought out scientific article after article and said, what about this, what about this, what about this? And it really impressed the judge, thinking that basically ID it's not really science. But in fact, what he should have thought was that ID is bad science. So it's a little bit weird, in my opinion. This is from the ruling, and we're going to talk about this in class. We've already briefly mentioned it a little bit, but we'll talk about this, in 2 weeks. Okay, so since that time period, it's supposed to be, if I remember right, the 17th century, science has been the discipline where testability, rather than any ecclesiastical authority or philosophical coherence, has been the measure of a scientific idea's worth. Methodological naturalism is a ground rule of science today. The idea is that ID violates this, that is, it invokes supernatural causes. If you remember, methodological naturalism is the view that science should proceed as if there is no supernatural. So maybe there's a God, I don't know. maybe there's angels and demons, I'm not sure. But scientific explanations can't cite them. Should proceed as if they're not there, because a scientific explanation is a natural one that requires only natural processes and laws. So the judge, again, this is now an official court document in the United, with the power of law behind it. Methodological naturalism is a ground rule of science today, which requires scientists to seek explanations of the world around us based upon what we can observe, test, replicate, and verify. Okay. It's worth pointing out just because I think it's so interesting, even though it doesn't help my point about what science is anyway, but I think personally the kinds of things that influence the judge very heavily in this case are, there's always these contingent factors in any particular court case. So here, one of the big claims at issue was, if intelligent design is really just creationism, well, creationism was already ruled religion by the courts. So if intelligent design is no different, then it will suffer the same fate. And so the defender, Dover, Pennsylvania, had to say, no, it's totally different. They basically had to say that we agree scientific creationism is religion, but we think intelligent design is different. But the problem is that the authors of this book that they provided are on record, provided affidavits in the McLean v. Arkansas case, no, that's wrong, in the Edwards v. Aguilar case, as creationists, and they wrote in the first edition of the book is a creationist textbook, and then the new edition is basically the same book, right? And in fact, so the prosecutors, of course, asked for all these documents. They're like, oh, send us the boxes of documents. So they sent them all these drafts of the book as it was being written. Computer files, save files, etc. And it was then possible to directly compare. In particular, mistakes are really telling. Right? So when they forget to change the copyright and various things, it's exactly the same book. Copyright, but this is supposed to be the intelligent design version, and that's supposed to be the creationist version. It's creationism relabeled. Let me just get all this straight up. Okay, so for example, here's these four different. The top two books are creationist works. The sentences are basically identical to this version from Of Pandas with People. Not surprisingly, Dean Kenyon is the author of all three, and it's the same person. But then here's the book that's supposedly not creation science. It's basically exactly the same. They just changed creation to intelligent design. And the real kicker comes when you look. This is just a statistical analysis. The word creation is mentioned almost 150 times in these books, and then suddenly not at all in the new edition. But what happened at the time? Did they sort of change those passages? Well, they suddenly just started talking about intelligent design, but the rest of the books are the same. And in fact, here's the real killer, I think, in my opinion. So it was clear what happened. Here, this is a mistake from cutting and pasting. So the word creationist at some point must have had two C's in it, in a draft, and they just did a find and replaced creationism, or creationist with design proponents. And so what ended up happening is that this, with the C in the ists, is still in a draft of the new edition. So the judge, quite properly, ruled that part of the intent behind this book was the same as creationism, which had, by precedent, had already been ruled religion. So, but that's a contingent fact of history, right? There's no particular, this is what I want to get at. There's no particular reason to think that intelligent design as a principle, so the idea that, for example, their complexity in nature is such that it's impossible to be produced by certain natural processes. There's nothing in principle religious about that. I mean, that's my own view. It's just that the actual implementation in this particular case is problematic because it was with religious motivation. Also, for example, they had cases of people lying in the stand. So Alan Bonsall, who was on the school board, said he didn't know where the copies from Of Pandas with People came from, which was in fact later found through email to be a direct lie. His father had arranged to get the books from somebody else and then make an anonymous donation and do it. So he knew where the books came from, and his father, of course, got them through the church and various things. So this kind of thing sunk the case, but actually has nothing to do with whether intelligent design is actually science. And if you want to read more about this case, there's a lot of great books here. In fact, there's a movie, which is you can just watch on YouTube, which is really good, Judgment Day, Intelligent Design on Trial. Okay, so now I'm going to say this interesting conclusion here. I mean, I'm not concluding right now, I'm leading to my conclusion. But wait, so let me rehash this discussion here. Okay, Popper publishes this book, says that science is testable, non-science is not, it's the key distinction. Philosophers like Michael Ruse think that's right. They testify in the court case. The judge agrees. Now it's law. Things like scientific creationism, intelligent design, and non-science, partly because they're not testable. For example, because they invoke supernatural causes, which are somehow not testable. And it all goes back to Popper, right? But there's this problem. First, I just want to point out that the question of whether some theory counts as scientific, I mean, it's inherently interesting. It's a good question. But it's also, it really matters. For example, it's part of the reason that we don't teach scientific creationism in schools today is because it's illegal, because it's considered not science. But there's this big worry. In my opinion, and the opinion of most philosophers of science, Popper's theory has some obvious, really basic problems. So I want to briefly sort of talk about that and then see whether we can reconstruct something close to Popper, which is good enough to get the conclusions that we like. I'm not sure we can. Okay, so first of all, let's go back to this good Popperian test, falsification. If H then O, so you have your hypothesis, general relativity, that predicts that the bending of light is going to be exactly this much around the sun. If it turned out that it was anything else, you would say relativity was false. Okay, but here's the first basic problem. What exactly are you observing? Now the way I'm going to bring that out is by going back to the supposed great test. Okay, supposedly this is what shows that general relativity is so great. I mean, there's many other things. General relativity is good, not just for this reason. But this was supposed to be this major thing that Popper talked about. But if you actually look at the details, as any good historian of science will tell you, like Barbara Hahn on Tuesday, as soon as you look at the details, everything is super complicated and much more messy than you would think. So here I'm going to point out, I'm going to rely, by the way, on this paper here by John Ehrman and Clark Leamore, two philosophers of science writing about the history of these eclipses. So Eddington was not alone. So remember the story, the naive version of the story is Einstein predicts bending of light, Eddington measures it, it's right, Einstein wins. Okay. The true story is much more interesting and much more complicated. So Einstein actually made two different predictions. First in 1911, based on the equivalence thesis, which he didn't have general relativity yet, he said that distortion would be this much. Then in 1916, he predicted it would be a lot more. And many scientists, not just Eddington, many scientists were eager to try to test this. And there was many other eclipses before 1918. So, for example, in 1918, it was known there was going to be this one across Russia, and a lot of people tried to get there. Now, the weather was a big problem. Turns out they couldn't actually see the eclipse. But in particular, these people from the Lack Observatory, that's in California, brought all... Lick? Is it Lick?
James Lick. Yeah.
Sorry. I would trust Peter Deere on that. So the Lick Observatory went to Russia, they brought all their equipment there, they couldn't see it, and then they couldn't get their equipment back. Their equipment was stuck in Russia because there was going to be an eclipse in the United States in 1918. But they didn't have their equipment. It was stuck in Russia. So they got this substandard equipment, I think from Oakland or something. They tried, it wasn't designed for the right kind of thing, but they basically tried to do this thing. They took these pictures, and if you actually check their measurements, they're not what Einstein predicted. They're much less distortion. And the person who did them, a guy named Curtis, was already convinced Einstein was wrong anyway. He's like, look, in 10 years we'll all know that Einstein's wrong, and I'll be famous because I sort of proved it. But the director of the observatory, Campbell, didn't really trust these pictures, and so it was never published. Their data was never published. But it was revealed many, many years later sort of what happened. In 1919, this is the one where Eddington went to Africa. In fact, there was another British expedition which went to Brazil to measure the same eclipse, and their pictures didn't get the distortion. But Eddington's like, yeah, my pictures are better. And he went ahead and published his, even though there's two expeditions, the same eclipse, they got different measurements. And in fact, even worse, Eddington's measurements were not what Einstein predicted. Now, he did get some distortion, so for example, his measurements would predict that the Newtonian prediction was wrong. But Einstein predicted, X amount, and he didn't get it. So, according to, the basic Popperian story, it should have falsified general relativity, but instead he's like, yay, relativity wins. So there's this really complicated story. Why? Well, go back to what exactly is the prediction, right? So if you say, this hypothesis, predicts, say, a certain amount of distortion, well, but if you don't trust your measuring devices, right? If you think, well, it's too cloudy, I couldn't get it, you think, that's not really the fault of the hypothesis. Okay, that's true. But as soon as you start to think about the logic of this, it leads to disaster. As soon as you realize that it's not just the hypothesis that's predicting what you observe, there's all sorts of other assumptions. Basic things like, for example, that your telescopes work, or that your pictures are trustworthy. But actually, even when everything is working, hypotheses basically don't entail any particular observations at all. Right? So take this really basic scientific law. Here's the law of universal gravitation. The force due to gravity is, you take the gravitational constant, you multiply by the masses, you divide by the radius squared. What does that predict? How would you test that? If you just think about it for a moment, it doesn't predict anything at all. Right? Or test F equals ma or something. It doesn't predict anything. Now, what you can do is, together with other things, so for example, if you think I have a situation where I know all the forces, and I know the masses, and I know that if you know all of that stuff, then it makes a prediction. So let me show you sort of how that works. Here's a famous case in the history of science, the discovery of Neptune. So you'll recall from our class that you can see the planets up through Saturn without a telescope. And then Uranus was the first planet discovered with a telescope. Possibly it was seen before, but nobody really recognized what it was. So that's discovered in 1781. So after they have the telescope, they have this new planet. And so of course astronomers are tracking it and plotting it exactly. Within a couple of years after it was discovered, Laplace, the famous mathematical physicist, basically predicted exactly what its orbit was going to be and said, okay, here's how Uranus is going to move so you can watch it. And they did. And it didn't move exactly like they expected. It was close, but not exactly like they expected. The period we now know today, the period around the sun of Uranus is about 84 years. So it mostly went around the sun. For 60 years, it had gone most of the way around, and they knew there's just something wrong here. In Britain, John Couch Adams, I guess starting a few years earlier, he was an undergraduate, and then on his summer vacation he did these calculations to figure out where the planet would be. And then this famous mathematician, Urbain Le Verrier in France, independently, just predicted mathematically. So they looked at all the details, they said, yeah, it shouldn't be like this. Let me sort of show you a picture of why it's off. So here, the inner one, so this is going to be Uranus. But the idea was, if there was a planet here, Neptune, then as they get close, this would be sort of pulled a little bit, due to gravity. And then as it passes, it's going to be pulled back. So it'll start to speed up and then slow down. Okay? And this is what they observed. So it wasn't exactly how it moved. And so these mathematicians, Le Verrier, gave a talk and said, yeah, it turns out if there was a planet with this mass in this location, it took him a couple different lectures, but by the third lecture he nailed it, said if there was a planet right there, in this exact area of the sky, with this exact orbit, it would explain the funny orbit of Uranus. And by the third time he said it, it took like a week or something for this a German astronomer in Berlin to just point out his telescope. Yeah, you're right, it's right there. So that's Neptune, the discovery of a planet basically by math. And if you think about what's going on, in fact, this is what we do today, right? This is how we discover planets. Not by looking at a telescope, but by doing math, right? We figure out, gravitational effects aren't exactly what we think. There's probably another planet right there. This is how we discovered all these other planets. But the reason it works is because Newtonian theory makes a prediction, predicts that the planets will be exactly there, and then they're not exactly there. But you don't falsify Newtonian theory. Everybody knows Newtonian theory is right? This is 1846. So it must be the fault of one of these other so-called auxiliary assumptions. So for example, there's another planet that you didn't predict, or maybe the mass of the sun was off, or something like that. But of course, this can't be general because sometimes it's the theory that's wrong. So a very similar thing, in fact, the same guy, Leverrier, within 10 years, predicted that, or not predicted, but had calculated, that there was this change. So here's Mercury has a very eccentric orbit. This is still not to scale, but relative to the rest of the planets, it actually looks like an ellipse. So Mercury goes around the sun. The perihelion, the point where it's closest to the sun, that's the perihelion, actually precesses, so it rotates. So it keeps going in an ellipse around, but the ellipse basically sort of moves over time. Okay? And Newton knew that this was going to happen. The reason is because there's other planets out there that sort of, slightly bother it every time it goes around. But how fast does it precess? Really, 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 really slowly. Okay? So the actual precession, something like, I think 576 arc seconds. So 1 degree in the sky, so the sky is divided up into 360 degrees. Take 1 degree. That seems pretty small, right? 1 degree of it. Well, for an astronomer, no, that's too big. So cut that into 60. That's a minute of arc. There's 60 minutes in 1 degree. Well, even that is too big. Cut that into 60, that's an arc second. Okay, so 1/360th of 1 degree. And it turns out that they did these calculations, and Leverrier, now he was actually off by a little bit, but he said, okay, here's the precession of Mercury that I measured. According to Newton's theories and according to all these other planets, it's off by 38 arc seconds per century. So over the course of 100 years, it would be off by less than 1/360th of 1 degree. But it was enough for an astronomer to say, this is wrong. But over the course of, and he predicted, for example, he's like, you're going to find another planet between the Earth and the Sun. It was called Vulcan. Some people were pretty sure that it would be there. He's like, the reason you haven't seen it is because the sun is so bright you just can't see it. But I, Leverrier, am convinced it's there. But they didn't find it. They couldn't find all this. And over the course of the next, I guess it's 50 years, they were so sure of their auxiliary assumptions, so sure that they knew all the planets, so sure that they knew the mass of the sun, so sure that they knew the exact obliqueness of the sun, that Einstein was actually convinced this is not like the Uranus case. In fact, Newton's laws are wrong. Right? There's a problem with the basic theory, but it's exactly the same setup as the other case. Right? The details of the case, now I think I'm out of pictures. So let me just sketch on the board. I know I'm going more than I thought, but let me sketch on the board this basic logic of what's going on here. Okay, so the thought is, here's Popper, okay? There's a hypothesis which predicts this observation. And so then if you find out that the observation is false, I'll just write it. Then you can conclude that the hypothesis is false. Okay, here's the problem. This is basically never true. Okay? You need the hypothesis together with these auxiliary assumptions. So for example, assumptions like, my telescope is working, my pictures are trustworthy, but also assumptions like, I know what the mass of the sun is, I know how many planets there are. Also assumptions like, I know whether space is flat or bent, right? There's all sorts of assumptions that are needed, logically speaking, to predict any particular observation. Okay? And now what happens is, in the best case scenario, you're absolutely confident of your observation. And so then what do you know? Really, all you know is that something is wrong. All you really know is that you can't have the hypothesis together with all your auxiliary assumptions. Okay? So, for example, you can't have F equals ma, the law of universal gravitation, and all the details of the planets, as is in 1846, because that would predict the orbit of Uranus, and that's wrong. But it could be the fault of one of your auxiliary assumptions, or it could be the fault of the hypothesis. There's no, logically speaking, there's no distinction here. Now, once you realize this, what happens, I'll just try to sketch, my view in the next minute. What happens is, it becomes, so there's something about testing that seems right. right? If you come up with a hypothesis that there's no connection to empirical reality, you're like, I think that the planets move around because there's little elves that push them as they move around. And you're like, oh, really? Well, how much do those elves weigh? Nothing. Oh, well, how fast do they move? Exactly as fast as the planets. And you tell this story where there's just no sort of way to test it. Okay, there's something wrong. But actually, basically any hypothesis can be made to predict something if you add the right auxiliary assumptions. So for example, if you believed that if the elves had, that the elves themselves would affect the speed of the planets, then you could test and say there's no elves out there, right? Or if you thought that you would be able to see them if they were there. It's the basic idea, like, how do you know there's not an elephant in this room? Well, because if there was, you'd be able to see it, and you can't, so there's not. That's the basic story. But all scientific hypotheses are like this. They depend on auxiliary assumptions, but any hypothesis is only, in a sense, capable of being falsified if you have trustworthy auxiliary assumptions. So this is what's happening, say, in my opinion, with evolution and intelligent design. So if you take, of course, it's even worse for evolution because it doesn't even with auxiliary assumptions, it makes no particular predictions. Yeah. So if you think about some historical thing, like, say, common ancestry, or that the dinosaurs died from a giant asteroid, or that they died from a virus, or whatever. So if you take something like that and say, what does it predict that you'll observe? Nothing. Certainly nothing by itself. What if you add various auxiliary assumptions, like, let's say, for example, how molecular evolution happens over time, and how natural selection works, and whatever. Still, it doesn't make any particular predictions about what's going to happen. What ends up happening is that you have, say, two hypotheses. You can say things like, well, common ancestry is better than chance plus separate ancestry. But what about, say, intelligent design? How does that get tested? Well, the thing is, if you had various auxiliary assumptions, like if you independently thought that here's how natural selection works, it works by blind chance, etc. Okay, well then, actually, intelligent design is testable. That is, there are some auxiliary assumptions such that when combined with intelligent design or creation science or whatever, it's really easy. Take a basic case like creation science. Is that testable? Of course it is. If they claim that the Earth is 6,000 years old, that's testable. You could just go look and say it's not. But that depends on all sorts of assumptions about our measuring tools. So I think things like, let's say, common ancestry as opposed to, say, separate ancestry with no story, as opposed to, say, let's say, intelligent design, which is consistent with either one. Okay. All three of these are sort of logically on a par with respect to how testing works, logically speaking. All of them need auxiliary assumptions to predict anything at all. So what's the difference? Well, in my opinion, what's happening, and we'll talk about this in class, not today because I'm going to run out of time, but later, what's happening is that the auxiliaries need it. So for example, if you can trust your theories of molecular evolution, or your theories of natural selection, or if you can trust your measurements of the planets and their distances, if you can trust those things, then you can trust the hypothesis when it makes a prediction and vice versa, and when it doesn't, then you know it's false. If the things that you need to add are themselves just as untrustworthy as the hypothesis in the first place, then you're not making any progress. So science, in a sense, is sort of tested as a whole, and I'll just say this sentence and leave it like that. We'll figure out what it means later. That is, it's really whole clusters. It's really common ancestry plus our theories about how molecular evolution works, plus our theories about natural selection, plus our observations of the particular traits that organisms have now, plus our theories about geology and how old the Earth is, plus all of those things together are what is sort of withstand scrutiny from data, from observation. And it is important that it has some connection to reality. If you ask about whether something else, say scientific creationism or intelligent design or chiropractic or anything like that, whether that's scientific, there's no logical answer. That was Popper's flaw. Popper wanted to say, take 2310 with me, learn some logic. Deductive logic will tell you everything about what's scientific. That's just false. What's really the important question is whether we can trust our other sort of various auxiliary assumptions going on here. And if we can't, then we're in this area where everything's on an equal footing. But if we can, then we can finally make these kinds of claims. Okay, so that's it for me. We only have 14 minutes left, but I'll turn it over to Peter to make as many comments as you like. You can take the whole time or no time, and then if we have questions, we'll open up for questions.
All right, well, this is a thoroughly unfair
Yeah, that's right.
requirement placed upon me. There were a couple of things that I thought about as you were talking there, Joel. One thing, though, that I do want to start off with, having to do with Eddington and Einstein, is there's a nice little story told by one of Einstein's graduate students at the time in 1919. This she reported in later years, which casts Einstein in a particular light. It also involves God, which is nice, though only in an Einsteinian sort of figurative way. Her story was that in 1919, a telegram arrived from Sir Arthur Eddington. You will Sir at that point. I'm glad, by the way, that you said Sir Conall Popper.
That's right, it's important.
A telegram arrived for Einstein from Arthur Eddington saying, yes, we confirmed your prediction about the shift in apparent position of the star that therefore vindicates general relativity. And Einstein's student said that she was enthusing to Einstein about how great this was, that the theory had been confirmed. And she said Einstein was completely unimpressed. He just sat there and he said, but I knew the theory was correct. And she said, well, what would you have done if the results had not come out in agreement? And of course we know they weren't exactly in agreement. But what would you have done if they had not come out in agreement with your prediction? And he said, then I would have felt sorry for the dear Lord. The theory is correct. Which shows what kind of an empiricist Einstein was. And it's a nice reminder that ideologies of science are not shared and take a similar form among scientists themselves. Scientists do whatever they do, and they like what they do, and they think it's right, but they're not continually checking what they're doing against some ideal form of scientific method that tells them whether they're doing it right or not. They just know what they're doing. They know how to do their practices, their own disciplinary practices. And that seems to be the case as much here as anywhere else. Another couple of things. All right. Judge Jones and the Dover, Pennsylvania creationism case. One of the things that Jones points out in his memorandum that justifies his ruling, which went against the school board, of course, was a point that he actually borrowed from Judge Overton from the Arkansas case 20 years earlier, where it was pointed out that the way that creationists were arguing, or intelligent design proponents were arguing, whichever you like, was to set up a false binary opposition between creationism, whatever term you want to use for it, and Darwinian evolution. So that they liked to argue that whenever there was a problem that you could identify, and they like to cite scientists, evolutionary biologists themselves on this, whenever there was a problem in Darwinian evolution, creationists like to take that and turn it around as if it acted as positive evidence in favor of creationism, as if it's one or the other, like a pro or a con, or like a courtroom battle where you have the defense and the prosecution, and there are only two possibilities: either you're right or you're wrong, or it's you're guilty or you're innocent. Judge Jones pointed out, as Overton had before him, that this is simply invalid. You know, just because you find problems in Darwinian evolution doesn't mean that creationism is therefore strengthened or is true in some way. It doesn't act as evidence for the truth of creationism just because you find a problem in aspects of Darwinian evolutionism. And of course, all theories have problems and have difficulties that need to be worked on. Random things. Yes, another thing, Popper. One thing to be said about Popper and the criterion of falsifiability is that although it's usually billed, and indeed was billed by Popper himself, as providing a demarcation criterion, as the terminology has it, such that you can tell the difference between what's real science and what's not real science. In a sense, that's not its most important characteristic, and Popper himself talks this way in various of his writings, particularly the more informal they become, the more clear it is. For Popper, the point about falsificationism and the falsification criterion for whether something counts as real science or not is a moral one. He wants to say that if you want to be honest, if you want to be intellectually honest, you have to open yourself up to the risk of falsification. And really it's that matter of the moral conduct of an intellectually proper and respectable scientist that's at stake here. Is this an intellectually honest person who is making these claims? And what Popper is saying is, if their claims don't come equipped with potential falsifications, then they're not being intellectually honest. And that's the way that he likes to clobber Marxism or psychoanalysis or something like that. Not so much by simply saying, oh, they're not science, so they don't count, but to say, if you structure things that way where they are not falsifiable, you are not being intellectually honest. Just because something's falsifiable, of course, doesn't mean it's true. In fact, typically, if something's falsifiable, it's quite likely to be falsified pretty quickly. But the idea is that it's a moral precept for the proper conduct of inquiry, as far as Popper is concerned, a moral precept rather than what one might think of as an epistemological precept or something of that sort. And that's why it's so important to Popper, and that's why I think in many respects it became such a great success, particularly in the post-war period. It's easily graspable, first of all, but also it's not simply easily graspable conceptually, but it also speaks to this moral point. Are you being intellectually honest? What the hell is going on with this? And that's an important point, that obviously with philosophical arguments of any kind, there are always moral valences lying behind there. And there are always senses of what it is you want to be true and what it is you don't want to be true. It isn't simply a technical matter of grinding through propositions and determining whether something is right or not. It's also a matter of saying, hey, what are the best arguments we can put forward to support our perspective? And that's always going to be the way. One thing I wanted to mention also, and this will be the last little point that I make, well actually no, there are 2 points, but one of them is a little one. Again, with Popper and falsificationism, and the idea that the falsification criterion is a moral injunction as much as anything else. The assumption there is also that if something does fall on the science side of the demarcation between science and non-science, as Popper is interested in doing, that basically what you're saying is, if it's on the science side, it's good. And if it's on the non-science side, it's not good. So science carrying this positive valence always, that's part of the assumption lying behind the use of the word itself. And when you see people talking about science in the various creationism, anti-Darwinian trials, also the word science is often being used that way. If it's science, it's good, and if it's not science, then you've condemned it in some way. And that's why it's important for some people involved in these trials to argue that creationism or intelligent design is not really science, not just as a technical matter, but in effect to say, therefore it's not good. So the use of the word science routinely carries with it, or is used to carry with it, these positive implications, again moral implications in effect, that this is a good way of making knowledge, this is a decent way of behaving. And Popper's falsification criterion speaks directly to that in a fairly directly operational way. The points that Joel was making about the problems about falsificationism were, of course, very quickly recognized by philosophers, and some philosophers tried to protect Popper's basic idea here by developing more elaborate expositions of the structure, the typical structure of scientific theories and hypotheses and all the rest of it, to retain the essential validity of Popper's central insight about falsification and so on. But they had to sometimes go on extra long trips to accomplish that. So there was most famously a Hungarian philosopher in the, well, particularly notable in the 60s and 70s, called Imre Lakatos, who was a student, had been a student of Popper's, and thought that Popper's approach was the right way to understand things. And he tried to develop a way of protecting or saving Popper's falsificationist criterion by developing a model of science where you would have some, I'm going to use some of Joel's marks on the board here, but I don't think I can adjust them appropriately. The idea is that you would have some basic hypotheses that you wouldn't want to give up too easily. Now, it was known by use of auxiliary hypotheses and so on that you can always protect things. When things seem to be falsified, you can always identify the problem as lurking in an auxiliary hypothesis that you can juggle with to try to protect the original hypothesis from being falsified. And what Lakatos proposed was that you could think of theories as containing a, what was the term, hard core.
Oh, protective belt, maybe?
Well, the protective
Yeah.
belt surrounds the hard
Right.
core.
Okay.
You have these basic elements of your hypothesis which you don't want to give up, like saying, you know, the Earth orbits around the Sun or something. And you say that, you know, that I don't want to give up. So in order to protect that from falsification, you have to have auxiliary hypotheses, a protective belt, to use the sort of graphic version of the notion, of auxiliary hypotheses that you can mess around with to try to protect the central core hypotheses from falsification. And the idea is that this isn't purely an arbitrary move, because what Lakatos says is that you can tell whether a theory is good or not, even though it is a matter of deciding by fiat, as it were, that you will protect that central core of assumption by juggling around the auxiliary hypotheses. He says the way you can tell whether the overall thing is a good theory or not is if the ad hoc adjustments you have to make in the auxiliary hypotheses themselves turn out to be productive in the sense of leading to new discoveries. So if you try to protect Newton's view of gravitation and mechanics in talking about the solar system, and you find that the planet Uranus is not behaving properly, you could say, well, Newton was wrong then, wasn't he? Newton's celestial mechanics is wrong because Uranus doesn't orbit in the same way as it ought to. Or you can set up the auxiliary hypothesis to save Newtonian mechanics by saying, well, there must be another planet out there that's disturbing the orbit of Uranus. And then if you go and look for it and find it, then hooray, you've confirmed, given extra reasons for believing in that original Newtonian theory, rather than simply chucking it out at first opportunity. And so Lakatos thought that that was a more realistic way of representing how scientific theories move forward, and how you can tell the difference between a good theory and a bad theory, that a good theory will be progressive, that your attempts to protect the core of the theory will generate new knowledge, and that shows that you're on the right track. And at the same time, he can protect the basic notion of falsifiability, even though as a technical procedure, falsifiability is actually a bit tricky to manage. But you combine falsifiability with progressiveness, and you get something that Lakatos thought would give you a better representation of how science works, and also will protect this notion that good science is good, that it is morally approvable. Okay, that's all I have to say.
Thank you.